Ryan. Thank you very much for helping out. Appreciate it. All right. First, I want to get to know the audience here a little bit. If you can get your phone out and just scan that QR code, we will go ahead and or go out to Slido.com and type in that number. I've got 3 questions for you. I know we got a Slido tab, but don't go over there because it only has one of the questions, so we'll use this to do it. And so let me go ahead and get that up, get it going here. The first question you'll see here is how experienced with the Algorand blockchain are you? So brand new to blockchain, you can choose up to 2 on this one. Brand new to Algorand blockchain, more than 6 months with any blockchain, or more than less than or more than on each one of those for blockchain or with Algorand. All right, so we're getting some early results in. Most of you are brand spanking new to blockchain. Okay, well, that's great. You're in the right place. We've got a good intro piece in the session here today. So we'll get you all up to speed on that one. Well, let's go over to the second question. So the second question here is, are you a developer? Yes, no, sometimes. In other words, hobbyist on the last one. Okay, a good number of you are. This is perfect, perfect, perfect. Looks like we're getting a good representative sample here, Ryan. Very good. And I'll go to the third question here, which is, what languages do you develop in? Check all that apply. I know we have a Java focus here in this session, but we do support multiple languages through multiple SDKs. And a good number of you are in the boat of Java and JavaScript, some Python devs. And we got one C# person maybe down there. That's good. Being from Microsoft, that is my preferred language. Java is probably my second because that's pretty close, right, to what C# looks like. All right, we got some more folks coming in. So a good number. Most of you are, 75% of you are with using Java. Okay, so you can check all that apply on that one. All right. Very good. Let's go ahead and get back to our regularly scheduled program and bring back the deck. So, interested in blockchain development. You know, what's all the buzz about with blockchain? What is it anyway, and how can I use it? What kind of solutions can I build? I know these were things that I had, questions that I had when I first, started learning blockchain. And, how do I get started is also a very popular question. And then, layer 1, layer 2, what the heck's the deal with that? What's in each layer? What is it? And what does a blockchain solution look like? What are the pieces that you do in a diagram on a chalkboard, for example, for piecing it together how a blockchain solution works? And how about the code? Show me the code. We are going to have code here today too, to satisfy women who code. And you're going to have lots of code here in this session here today. Show me the tools. So our agenda, we're going to go over some use cases. So that should give you a good feel, why blockchain and what you can do with it. And then we're going to cover some of the basics about blockchain and dive into layer 1 and what exactly that is and the tools, all the tools. So blockchain use cases, we got the props network is the first one I'll share with you. It turns app users into loyal financial stakeholders. So they have a sample API for loyalty programs, widgets for mobile apps, and it's really an ecosystem for token holders. So anytime you have a loyalty program, many of you belong to those, either at your stores you shop at or online sites. This is something that you accumulate points for, right? And you can redeem later for that. So they're actually using this feature called Algorand Standard Assets to do this, or tokens is another way to put it. And we'll show you how to do that and talk about what those are a little bit more in depth. Another one here is the Italian Society of Authors and Publishers. they provided digital copyrights, and they just ported over last month, I believe, about 4 million NFTs. And what's an NFT? A non-fungible token. And it's another form of a token that we talked about on the first slide, but this one here is unique. It represents a kind of like these can be used for collectibles or things that are one of a kind. And so copyright's like one of a kind. And so the beauty of it is decentralized, and it's a transparent public blockchain. So this is exactly what copyright authors want to have. They want to have it accessible, being decentralized no matter what country you're in, and then also transparent, right, to be able to see it publicly. So this is a perfect solution for a blockchain implementation. End-to-end protection, the future of the industry really is using this particular approach. And even so, I don't know if you've ever seen Saturday Night Live, but there was actually a skit a few weeks ago on NFTs and blockchain. So guess what? We have officially hit the mainstream, right, with blockchain type solutions when you see your a skit related to your technology on Saturday Night Live. So anyway, Circle and Coinbase, the central consortium, one more here, payments and treasury infrastructure. They accept payments, both traditional payments as well as crypto. And so this is a very, very good use case. In fact, they have something called USDC, and this is referred to as a stable coin, billions in circulation. So what is a stable coin? Well, it is an asset like we talked about. But one of the problems with cryptocurrency is the fluctuation, right? One day it could be very high, the next day it could be very low. And that really doesn't lend itself for transactions because, you can pay $20,000 in Bitcoin. Next day it's worth 10,000. So this is really the nature of cryptocurrency. So what USDC does is it ties itself to a fiat, a government's fiat. And in this case, this one here is tied to the U.S. economy. So it will fluctuate with the U.S. economy. So it's a lot more smooth in terms of the ups and downs and the peaks and valleys. And it really makes a lot of sense to do transactions with a stable coin. Other use cases, tamper-proof charity organizations. These are all from the China Blockchain Report 2020. The ministry is using this to improve transparency of social services. So knowing exactly where donations are coming from and where they're going to. There was a problem with I think it was a big tsunami that hit about 10 years ago that the Red Cross lost track of where the donations were coming from and going to, and that's really a disaster, right? When you're talking about especially charities, you really want an audit trail. Audit trails are something you get built in for free with blockchain, and it's one of the big characteristics of a blockchain is the fact that it's immutable. There isn't a record, and it's very easily detect if any tampering has been done. Voting, another great scenario. Once it's verified, written to the blockchain, there's no ifs, ands, or buts about the votes. Tamper-proof. Healthcare, global access, medical records, automotive industry, very good in terms of supply chain visibility. And what they're doing is they're putting sensors into used automobiles to detect the wear and tear, as well as some new automobiles. And this data gets written to the blockchain and is publicly available. So you have trust now, right? Traditionally, car salesman is associated with lack of trust because they just want to sell the car. But now there's a solution to that. Where you actually have a detailed record of the what's happened to that car during that particular ownership period. But the biggest area by far is DeFi, right? Distributed finance exploding on the blockchain. In 2020, there was over $1 trillion in cumulative blockchain network value. 1 trillion. And it's getting better, right? And bigger. 2021, projecting over $3 trillion in the blockchain industry. And those are all in the Massaro report. Algorand DeFi examples are IDEX, Monerium, POKT. You got stable coins like Tether, USDC, MELD. These are all out there. And then also there's really a big ecosystem now. Our blockchain's been around for 2 years. It's a modern blockchain. Now I'll go over some of the benefits of the Algorand blockchain versus, some blockchains that are like 10 years old in a few minutes. But basically a lot of technical ecosystem integration. We got a lot of SDKs you can see in the upper left corner. Financial infrastructure, many companies represented there, as well as a lot of applications and solutions being built. We are one of 3 blockchains with the top 2 stablecoins, USDC and USDT. So let's get into some of the basics. So a blockchain, what is it? It's an immutable distributed ledger. And there's traditionally 5 types of record types that you can associate with this distributed ledger. The first one's a block. What is a block? Well, it's a time slice. It's a time period. The blocks on the Algorand blockchain are burned every 5 seconds. So during those 5 seconds, any transactions that are recorded are associated with that slice of in time. So a block can contain many transactions. Transactions are associated between accounts, a from and a to, as well as different types of accounts, right? And also you have each account can have multiple assets and multiple applications. Assets are the tokens that we talked about up front. Applications could be smart contracts that would be associated with that particular account. So those that are brand new to blockchain, which most of you are, basically the way it works is, blocks are burned to the blockchain, 1 block at a time. And some of you may have heard of forks or proof of work with other blockchains like Bitcoin, for example. And basically, we don't use those. And, the proof of work is a very, very non-green approach, right, to instantiating a new block on the blockchain. In the case of Bitcoin, very expensive and powerful and electrical consuming computers compete to win a problem mathematically, and then they get to write that one to the block, and that's how it works. As a result, forks are created, so you got some parallel competitors trying to issue blocks to the chain, and so a lot of times those will get orphaned, which doesn't lend itself to good performance. So more specifically, this can be represented with the Byzantine generals problem. So back in the day, you had several generals that needed to communicate with each other in order to whether attack or not on the empire. Now you have messengers that go between these generals, and if the messenger goes around and gets all the communication done, fine. Everybody's got enough supplies, everybody's got enough food, everybody's got enough, soldiers. And then what happens is, maybe 1 or 2 of these messengers might not make it. Maybe there's bad weather. Maybe they break a leg, or maybe they get corrupted. And there's a lot of things that can happen. So if you don't have a consensus, the decision to go ahead and attack the empire could be based on a false assumption. And that's where we get what you really want is a consensus. Now, the problem is the expense that's involved once you scale this. If you start going to, say 10 generals, the expenses are generally going to be 10 squared. If you go to 100 or 1 million, you go to 1 million folks involved, then the expenses will be 1 million squared. So it really increases exponentially. So Sylvia Macaulay, founder of Algorand, a Turing Award winner, figured it out. You really don't need everyone to participate. What you need is a representative sample. And that is accommodated through the verifiable random function, or the VRF, which is open sourced on the Algorand GitHub repository. So when I started working with blockchain, there were some terms that kept coming up. People were talking about permissioned blockchains or permissionless blockchain. What are these? Well, basically, a private blockchain is a permissioned blockchain, and a public blockchain is a permissionless blockchain. So by being permissionless, that means anyone can join, read, write with the blockchain network. Now, by write, it's write once, right? So like we looked at the ledger diagram that we had a few slides ago, where we had a new block being created every 5 seconds. Well, that's got a very good hashing algorithm, right, to get to that particular spot in time, and it's very easily detectable if any blocks before it were tampered with. So it's basically a read-only blockchain, the exception being the new block being burned to the chain, and that would be writing it. So it's decentralized, no one has control over the network, it's secure, and data cannot be changed or once it's validated. Now, the other hand, you have permissioned blockchains, so restrictions who, it restricts who is allowed to participate. Now, typically you can be allowed in select transactions, or authentication would be required on those. So what type of apps can be built with these? So public and open very easily can be building, currencies and betting and video games that kind of make sense, to have those type of things public and open. And then you get to public and closed in the upper left corner, things like voting. You want the vote results to be public, but maybe you want it to be closed until a certain time of day. Bottom right, private and open, supply chain, government, financial records, corporate earnings statements. And then the most secure ones would be the private and closed, right, which would be around national defense, law enforcement, military, and tax returns. Well, you can really build any one of these solutions with a blockchain, a public blockchain. So public blockchains like Bitcoin, Ethereum, Algorand, all fall into that category. But with Algorand, we have a note field, for example, that you can put a user-definable function in, or structure. And the note field is on transactions at the transaction level. So it's really up to you and your developers to create an authentication model that would facilitate that from a layer 2. And we actually have some third-party vendors, OREs, and one I can think of is a product that does do that. And so there's solutions out there that would facilitate really creating a blockchain solution for one of these, any type of these categories that you see here. And what is the protocol referred to as? The Algorand blockchain pure proof of stake. And it's very scalable, over 1,000 transactions per second, under 5-second block times. Versus like Bitcoin, for example, it could be 10 minutes, 15 minutes right before you get a block created to the blockchain. Well, by having it under 5 seconds, this facilitates point of sale transactions very easily. And also it has true scalability across the globe. Infrastructure longevity. We've got a lot of technical flexibility. Many SDKs are being created. The community is just flourishing with tools. Transaction certainty. Once you do a transaction, it's not going to get forked off. It's going to be put to the blockchain. Very extensible platform, as well as energy efficient. You can run a node on a Raspberry Pi. That's how efficient this is. And very, very green blockchain. And then you get to cost efficiency as well. Transactions are 1/100th of a penny, in cost. So really very inexpensive to do that. The gas fees on Ethereum are much more expensive, and this has really become very attractive for a lot of major corporations to look at Algorand's pure proof of stake as a way to do great blockchain solutions, and provides true security like we talked about as well. There's a great video. I'll leave this as a homework assignment. I am going to have a link to the deck at the end. We'll provide that in the chat as well later on. But basically, you have a pure proof of stake video here that explains that census model very, very nicely. Now, layer 1 features include basically built into right to the blockchain is really what it's talking about, as opposed to layer 2 are solutions that are built on top of it. Scale is needed for a global blockchain. So the features that are built in the layer 1 really have to be lean and mean and be scalable. These features that are built into the Algorand blockchain are ASA, or Algorand Standard Assets, atomic transactions, and Algorand smart contracts. So let's talk about these. So ASAs create native tokens, administrator functions, asset spam protection, right? You can't blindly, send out assets to any account. They have to want to receive them. And this resides on layer one. Example, something that resides on layer one. So there you can see on the right, a little visual tool that is available to create assets. And you can see the total supply you put in, what the unit name is, and just hit create. And then a lot of management functions as well. So you can have accounts that are responsible for clawback functions or freeze functions or overall management or the reserve. So that's really well thought out. Now there's two types. We kind of alluded to this earlier on. You have fungible tokens. Each one of these are identical to each other. So examples of that would be stable coins or system credits or cryptocurrencies. Also, you have restricted, so you can have clawback on those with securities. Non-fungible tokens. This is really the rage. There's so many articles and press around non-fungible tokens this year. It's really mind-blowing, but basically you can use it for real in-game items, that the players are in control of themselves, right? If you earn a token, it's yours, right? And then you can spend it any way you want that is available. Maybe the game vendor has a token store where you can redeem for merchandise, that sort of thing. So then you have supply chain, real estate, identity. These are all examples of non-fungible. Real estate would be, say I've got a 2-bedroom condo here in Newport Richey, Florida, where I live, and on the other side of town, there's another 2-bedroom condo. Well, they're worth different values, right? There's different metadata associated with each one of those. The neighborhood, how close you are to the water, all that kind of stuff. So a lot of things that make each one of these unique. Collectibles, good example there. So those are assets. And then AlgoDesk is a great tool that you can use here to go ahead and create assets. This particular AlgoDesk IO is written by a partner. You can do smart contracts at Web Wallet. You can build contracts. Also, there's an asset manager here where you can go ahead and get started with this. This is your private key. We'll go ahead and get started and go ahead and hit that. And then now we're going to go ahead and create an asset. So this will give you, we'll go Pizza Rust, P Rust, total supply, 10,000. You can have a decimal point. So it'd be 10,000.1 of these, specify a URL. And then these are associated accounts with that. So we go ahead and create it, and under 5 seconds, this transaction runs, and then you'll see that listed at the bottom of this page. We'll scroll down to take a look and see what got created. And you can see it right down here, Pizza Russ. And these are all the addresses that are associated with those functions. I hit the ... You can see send assets, modify, you can freeze. These are all the functions, the life cycle, right? That's available with an asset. Also, we have block explorers. So if I open up this asset in the block explorer, this is the Algo Explorer. There's also a few more that are available, but then you can see, the information that just happened, right? This just got created a few moments ago, 41 seconds ago. You can see it right down over here. And there you have the reserve address. If you click on the address, you can actually see information associated with that account. So these block explorers can be used to search transactions IDs, blocks, asset names, and accounts. There's also a test net, main net, beta net switch right there. All right, and then the other thing you could do is you got this Algo Signer. So Algo Signer is a similar to it's like a MetaMask type Chrome plugin. In other words, a wallet that's available to sign transactions. So it's a Chrome extension, and you can just integrate with this with your applications that you write. And I think I fat fingered that. I'll try it again. Oh, I didn't. Okay, there it is. So now you can see I've got my account right here, and I can go ahead and do a, send a transaction. I can go from my address here to, I can paste in an address. I can go ahead and send, one algo to that, hit send, and then it'll be on the blockchain as well. So that works pretty cool. And then let's talk about atomic transfers. Atomic transfers, basically all must succeed or all will fail. So the example here is you have person A that wants to send person B 50 algos in exchange for a concert ticket. If person A doesn't receive the concert ticket, they don't lose the 50 algos. It's got to be all or nothing. and very analogous to SQL Server transactions for those of you that are familiar with SQL Server. And what this does is it guarantees exchange of goods. This is the secret sauce on building a solution in blockchain, is being able to tie together multiple of these scenarios together into one big transaction. You can also combine them with other Algorand technologies like ASAs or smart contracts. And examples include circular trades, group payments, distributed payments. That brings us to smart contracts. This is TEAL is our transaction execution language. It's a non-Turing complete language with assembler. It's assembly-like. There is a Python-enabled compiler that you can use to write the contract in PyTeal and then generate the TEAL. Again, the thought process has got to be very lean and mean on the blockchain on layer one. But there are tools now that are being created to help facilitate it a little bit easier in language of your choice. And I'll talk more about those in a minute. Two types of smart contracts. You have stateless and stateful, with approved spending transactions with stateless. So it either returns true or false. If it returns true, then it's going to approve the transaction. If it returns false, it will reject it. Stateful also provides a global and local storage, so local at the account level or global so the entire blockchain can see it, and combinable with other technologies as well. Stateless smart contract, you have two types, a logic account, you have a logic signature, which also includes a delegated authority to sign off. So logic accounts typically could be used for escrow style payments, split payments, or hash time lock contracts. Recurrent payments would be best used with a delegated authority. And then there is a life cycle associated with stateful smart contracts. You have to create the application. You have to opt in to use it, just like you have to opt in with assets to use it. There's no opt that actually calls the application. You can update the application as well, delete it, close it out, and clear state as well. So Algorand accounts, you have a standard account, which is one account. You also have a multisig account, which is has a threshold typically. So say out of these three accounts that are in the middle, two of them have to sign off on it for it to be approved. So it's a group, and you specify what the threshold is. Kind of like when you go to a bank and you need to have the check signed by two people to cash it. Logic account we talked about, right? It returns true or false, and that will sign it accordingly. Finally, what about reporting the data and getting at the data? There's an indexer that facilitates that. It retrieves data off the blockchain and writes it to a PostgreSQL database. So very, very flexible, accessible from all the SDKs. You can get the indexer through the private network, which is available in Sandbox. Also, there are services available, or you can build your own, all documented on our site. And then here is the combining architecture, what it looks like. You have a voting commission, for example, and a voting example here, and combining layer one features. Now, these are all atomically grouped. They all have to work or nothing group. So you get this voting for candidate A. Then you have some logic that get executed with a voting smart contract. If that's successful, then this will increment candidate A vote total and global state on the blockchain. Another typical scenario is crowdfunding. Again, all of these are atomically grouped. You have the crowdfunding escrow account. If all your funds are met, then everything is a success. Now that would be a stateful smart contract. Then down below, you would approve it maybe with a smart contract that would be a stateful one. And so these are the scenarios that you can piece together for a blockchain type solution. Now on the tools, we got a great developer site, developer.algorand.org. Encourage you to take a look at that. Lots of tutorials, solutions, and articles. And these are the networks I've been referring to. BetaNet, we have a new protocol release coming out soon, so that'll be in BetaNet. And then testnet and mainnet always mirror each other. So the idea there is if it works in testnet, it'll work in mainnet. So mainnet is your production environment. And then private networks, you can kind of mirror any one of these environments with that. And that's a brand new one that's from scratch. I like to refer to that as a personal network right on your machine. And so very good for building applications with that type of a network support. As far as nodes go, this is really your copy of the database. You know, being a distributed blockchain, everybody's got access to the ledger. And so that would be your node. And if you don't want to create your own node, you don't have to. You can use services to do that. PureSake and RAN Labs provide those. Also, the sandbox is a very easy way to do that with from a developer standpoint. So just clone the sandbox GitHub repository, install Docker, and you're on your way. Just do sandbox up. That brings up the private network with indexer, and then testnet use would be sandbox up, and then you put a parameter. All the networks are supported with that. Code tools, great SDKs. And let's take a look at some demos here now. All right, so the first demo I'm going to show you, I'm going to bring up the code. Now, this is the sandbox actually that's running right now. So you can see these are the addresses and the tokens that you would need to put in the code. So to reference and instantiate the client. So more specifically, here is the Java sample code. So let's go ahead and create some accounts first. And I'm just going to run this, and I've got a breakpoint set here. And what you see here down below is going to be the accounts that get created when you go to run this. And there they are listed. So you've got the account, and then you also have that mnemonic phrase. Now, the mnemonic phrase we're going to use in the next demo. But here we see we've got an address. So what we want to do is fund that for testnet. Because right now, initially, it has 0 algos. So what we do is simply go out to the browser and go out to a dispenser, and then go ahead and paste that in, and now you've got some funds available to utilize that. So we have a status code of 200. That's a success. So now this particular account has funds. Why do you need funds? Well, there are transaction fees associated. Whenever you send algos, you'll need to pay for that. And so that gets you all set up and running in the testnet environment. So let's do a transaction. So I'm going to go ahead and do a first transaction. And so this one here is going to populate that account with the code right here. So there's the passphrase. Now, you would not normally do this in a production application. You get the private key, which is what this is, from something like AlgoSigner or from MyAlgo or from any other approach that manages private keys. So, but for demonstration purposes, we're going to instantiate this account using that passphrase. And we're going to continue executing this. And then what we'll see here is the first thing we're going to do is get some transaction parameters. So the transaction parameters are going to be things like the suggested params, right, that you have for, the fee structure. I love this new feature, by the way, in VS Code. It just automatically shows in Java, all of these fields here highlighted. It's great. Don't even have to hover over them anymore. Everything is right there. That was like just a couple days ago. I just started seeing that. I was like, this is wicked cool, as they say up in New England. All right. So then I go to the payment method, right? So I go ahead, create my transaction. That's step one. Step two is sign the transaction that you see there on that line. And then the last step is go ahead and broadcast this out to the network. Now, if there are any problems with that transaction, that's the step it'll show up in. It checks for things, the consensus checks for things like having sufficient funds, or make sure you're not double spending, that sort of thing. And this wait for confirmation will wait, up to 5 seconds, typically for that transaction to run. And then I print off the transaction down below so it has completely succeeded. So now there's another choice you have to code. There's really a great tool called Algodia. And this particular tool is all visual. So I can do the same thing. I can go ahead and right mouse click and say, go ahead, bring up a list of accounts, or I can create a new account right here, like you saw me do. But here I'm just going to list the accounts, and then I can fetch the balances, and I can see what they are. So you have the ability, number one, to set up your environment for multiple nodes, and you can say, okay, I want to use the pure stake node this time. Maybe next time I want to use the local node. Here's a sandbox node, and you set all these up as a developer. Now, I'm going to show you a smart contract transaction right here. So what I'm going to do here is I'm going to go to the Algorand. I'm going to say I want to do a new stateless smart contract, let's say. And so that's an LSIG, a logic SIG. And what I'm going to do is a delegated signature. So a delegated signature, you need to sign off with an account. So I'm going to send some money from Alice to Bob, and I'm going to hit OK. Now, this teal that you're looking at in the background is a very simple example, but basically the receiver, which is Bob's address, has got to be less than or equal to 1 algo. So this is a micro algo, so 1 algo. And that's the logic. And if it passes that, it succeeds. And so what I'm going to do here is just go ahead and then say I'm going to send a transaction, a logic SIG transaction, and if I pick Bob as the receiver, it's going to work. If I pick any one of these other ones, it would fail. And I'm going to say 1 algo and then hit it, and now it's going to execute that, and it's going to sign off by that particular contract is what is being used. So a very nice approach to that. And the next thing I want to show you here is a multisig account. Let's go back over to the code in VS Code, and I'm going to show you multisig here. And what a multisig account is basically multi-signatures, right? So the first thing you got to do is you got to set up your multi-signature account. So this is how you set it up. You have a multisig address function. This middle parameter is the threshold. So 2 out of these 3 public keys are going to be used to sign off. So that's our object MSA. And then we take that object, and then we use that in the transactions down below. So we're going to go ahead and get our transaction params like we did before. Now we're going to say, okay, I've got a transaction builder. I'm going to go ahead and create my transaction. And then these 2 lines are the 2 sign-offs, right? I got 1 by account 1, 1 by account 2. And so those will get executed, and then I'm ready to send that raw transaction and broadcast it out to the blockchain. So that's how that works. Now, the other one that's very important to review here is atomic transfers. So if I take a look at the atomic transfer code and what's going on there, and again, you can use that last environment I showed you, Algodia, to do all this visually, and sometimes it's faster to do that and then come up with code. Sometimes, most times, probably. But here, I like going through the code because you actually see what's being done under the covers that Algodia was, and it's better to learn from that. And all these code examples are up on the developer portal as well. So we have the 2 transactions. The first one's going to go from account A to account C, and we're going to send 10,000 microalgos. The second one's going to go from account B to account A, and that's going to be 20,000 microalgos. So those are going to go into a group, which you see right down here. And then the group passed into the transaction that gets broadcast out to the network. So sign the first one, sign the second one, and then boom, there you go. You got the raw transaction being sent out to the network. And then finally, let's take a look at the indexer, some indexer solutions. So if I go and take a look at, for example, I just want to get information on a block, Indexer will instantiate the host. Here I've got one running locally on my machine. So I instantiate the client right there. So once the client's done, then you can have several methods available to you. For example, if I hit this dot here, you can see there's lookups, there's searches, right? So I can look up by account ID, transactions, application ID. So really you can search in assets, transactions, accounts, and multisig. So those are all available to do your searching. So if I hit the run button here, this is simply going to print off the information down here for the block, and then you should see the response be displayed right down below. All right, so there you have that being done.
Russ, I think we're at about time here.
Yeah. We got like another minute or so, and let me just wrap it up here. That's exactly what I wanted to show you here, demo-wise. So we got all those in. Let's wrap it up. Thanks, Ryan, for that note. I just want to talk about the some great tools here that we looked at on the community. There is a community page that you can go ahead and take a look at there. One I do want to mention, though, before we close is Reach. This is a really great tool. This will facilitate building blockchain solutions to multiple blockchains at once with one set of code. So if you have a solution that you want to write to Ethereum as well as Algorand, you got one set of Reach code, which is JavaScript-like, and then now there's a new RPC front end where you can use language of your choice. The three that they have done at the moment are Go, Python, and JavaScript, and it's very conceivable Java will be supported in the very near future on that one. So keep that one in mind and go out to Reach, the Reach site there, and go through the tutorial. I highly recommend that. We talked about AlgoSigner. MyAlgo is one that's not available. It does not need a plugin that works for web-based solutions. And Algodia we looked at. A lot of reward programs. Ryan, you can go ahead and post a link to the deck in the chat window. And then also you've got a great program of ambassadors, over 66 countries represented. This is like our MVP program. So contact Stephen at Algorand Foundation. Some great resources as well for homework assignments. We got an office hours tomorrow, 12 p.m. Eastern time, and we're going to have folks from Reach doing some content there for us as well tomorrow. First and foremost, you might want to take a picture of this, or Brian, maybe you can paste this Discord channel in right here as well. This is the one you want to have to join to get any kind of support. Is over, I think, 8,000 members now. It's growing like a wildfire. So check that out. Here's the link to the PowerPoint too, and more resources are in the deck as well. So in summary, we covered a lot of ground here today on blockchain use cases, Algorand blockchain basics, and how this is really just a distributed ledger with a handful of record types. It's nothing mysterious. It's very, very simple in concept, really, really simple in execution. And layer one features, we took a look at how important it is to have those be scalable. You can't put a very hog-intensive virtual machine on those. If you did put a virtual machine, it's got to be lean and mean as well. And we will have some announcements on that coming up very shortly as well. A lot of great tools. We have SDKs and all the major languages, and a lot of great tutorials on the developer portal to get started with. And don't forget about looking into that Reach tool to help build your applications with. I'm going to leave this slide up once again. This is the PowerPoint, and I'd appreciate it if you can fill out this to give us a little bit of feedback on this session. I'll go ahead and paste that in the chat window, and then also I'll go ahead and paste in the Discord as well. And if we got any questions verbally, we can. Otherwise, Ryan, if you can please copy off that log, or actually I can do that probably at this point, and we'll turn it over to Sapphire for any closing remarks. So thank you very much, everybody.
Thank you. That was an awesome talk. And I could see that our chat was active, and Ryan, you were answering a lot of questions as well, so you got them all covered, I see. And we see everyone coming in saying thanks. That was amazing. Thank you so much, Russell. And thank you, Ryan, as well, for all your help too.
You're welcome.
Yeah, our pleasure. And happy coding, everybody. Join the Discord channel I just put in there, and that's a wealth of resources right there to get you running and going for building blockchain solutions going forward. Thank you very much.
Thank you. I see that someone just had trouble with the slides. You just have to download them because the file is large, and you'll get access to them there. So just to let people know that. And also, this talk as well will be available on YouTube in a few weeks' time. So I know some people's having trouble with the browser there, so don't worry, it's going to be recorded and you'll be able to see it all then afterwards.
All right. That's great.
Thank you. I hope everyone has a great day at the rest of Connect. So I'll see you all later. And again, thank you, Russell. I hope you have a great day.
Okay, thank you. You too.
Bye.
Okay, very good.